In today's session, we are going to discuss the last physical trend and very important, ionization enthalpy. So what is ionization enthalpy? Ionization enthalpy is an energy required to knock off valence electron in its gaseous state. When we talk about removing of electron from its valence shell, it requires energy, and that energy is ionization enthalpy. Whenever there is a strong attraction between nucleus and valence electron, it requires more energy. Whenever there is less attraction, it requires less energy. Let's understand this ionization enthalpy by taking example, and that example is as we move down the group, what happens to ionization enthalpy? Let's take the example of group 1 elements, lithium and sodium. When I talk about lithium and sodium, let's remove one electron. The amount of energy required to knock off this electron is ionization enthalpy. The attraction is more in case of lithium, and as you move down the group, number of shell increases, and that's the reason attraction between center of the nucleus and valence shell decreases, and that's the reason as we move down the group, ionization enthalpy decreases. So this is about ionization enthalpy as we move down the group. Let's consider ionization enthalpy across the period. When I talk about across the period, the example is with lithium, beryllium, and with sodium, it's magnesium. Let's remove the valence electron from beryllium and from magnesium. The amount of energy required to remove this valence electron is ionization enthalpy. Let's compare lithium and beryllium now. Attraction of valence electron is more in case of beryllium or group 2 elements. Reason being, atomic radii is less in case of beryllium or group 1 elements. So, as we move across the period, atomic radii decreases, and that's the reason ionization enthalpy increases as we move across the period. So, beryllium's ionization enthalpy is more than that of lithium, and that is what is conclusion. First ionization enthalpy of group 1 elements are lower than first ionization enthalpy of group 2 elements. Or we can say, as we move down the group, ionization enthalpy decreases, and as we move across the period, ionization enthalpy increases. So this was about first ionization enthalpy. Now let's talk about second ionization enthalpy across the period. When I talk about second ionization enthalpy, let's consider lithium and beryllium, which has already lost one electron, and now we will talk about removing second electron. The amount of energy required to remove second electron is considered as second ionization enthalpy. Attraction is more in case of group 1 elements, and that's the reason we say second ionization enthalpy of group 1 elements are greater than second ionization enthalpy of group 2 elements. Or we can say, as we move across the period, second ionization enthalpy decreases. So this was about ionization enthalpy of S block elements. Now it's a question time. I'll give you 3 questions and you have 40 seconds to solve. Your time starts now. So students, simple questions. Let's see the answers. The first question, ionization enthalpy is dash as we move down the group. As we move down the group, attraction decreases, and that's the reason ionization enthalpy decreases. Answer option C. Magnesium first ionization enthalpy is dash than that of sodium. The correct answer is it's more. When we move across the period, ionization enthalpy, and specifically first ionization enthalpy, increases, and that's the reason group 2 elements ionization enthalpy is more than that of group 1 elements. Third question, second ionization enthalpy is greater in case of. When we talk about second ionization enthalpy, as we move across the period, ionization enthalpy decreases. So it's maximum with group 1 element. Answer option C. If you got all the 3 questions right, you got 3 on 3. Thank you.